Hi again, Year 11. Today we're going to move on from those four energy stores and we're going to look at applying the two power equations that we need to know. So today's stuff is going to lean heavily on those four energy store calculations, but we're adding a little bit more to it. If you haven't had a chance to do the do now yet, please have a go and then come back to the video and check that you've got the right answers. Okay, so our first equation, what is the equation for kinetic energy? We should be getting quite familiar with this one by now. It's 0.5 mv squared. The equation for gravitational potential, again, something we've seen a lot now, mass times gravity times the change in height. The gravitational field strength at Earth's surface, G, is 9.8 newtons per kilogram. What unit should the extension be in when calculating elastic potential energy? It needs to be in meters. And how do you convert from grams to kilograms? So if you start off with grams and you want to go to kilograms, then you will need to divide by 1,000. If you're going the other way, you multiply by 1,000. Okay, so straight on with a direct instruction. So we're going to introduce this concept of power. It's defined as the rate at which energy is transferred or the rate at which work is done. So you might have seen the idea of power when you've looked at electrical appliances. That just tells you how much energy that electrical appliance uses every second. So a typical kettle might use something like 2,000 or 2,500 watts. So that's telling you that every second that kettle converts 2,500 joules from electrical into to heat energy or sound energy. So if you do want to work out what the power is, you'll need to know how much energy is transferred and how long it's taken to do that. We might also use the term work done. So we mentioned this a while ago, that work done and energy transferred are the same. This is probably the best to use, but energy transferred is just as acceptable. So we'll start off looking at an example. We have a student who's walking up some stairs. There's 3.2 meters high, and the question tells us that they've done 2,240 joules of work climbing those stairs. So they've used that much energy getting to the top. So that's been converted from chemical energy all the way into kinetic, into potential. So when they're at the top, they've got potential energy. They've got 2,240 joules worth. And it also tells us that it took them 2.8 seconds to get up those stairs. So we can use our power equation. So power is work done over time taken. That work done was 2,240 joules. That's divided by the time taken, 2.8 seconds. So 2.8 seconds. Type that into our calculator. 800s. That's quite a good power. 800 watts. So that's quite an interesting number. It's actually more than a horsepower. So I'll go off on a little tangent and talk to you about the idea of horsepower and different units for power. So nowadays we use watts, but when people first came up with the idea of power, they wanted something that people would use in everyday life, and they would be able to compare how much power this machine used to something that they had seen every day. So the thing that people used to use to do big heavy tasks were horses. They'd pull ploughs and things like that. So people were going to understand that a horse can do quite a lot of work in 1 second. If you had a machine that could do the work of 10 horses, that would be quite impressive. So you could say your machine had 10 horsepower, and they still use that in cars today. We stick to watts, and 1 horsepower is equivalent to about 746 watts, I think that number is. So this person has more than 1 horsepower when they're running up the stairs. I'll stop digressing now, and I'll have a look at what we'll actually have to do. So this is a typical question. So all the ones we're going to look at today I've seen come up previously in exams. So we need to work out power and that is going to be energy transferred or work done. I'll use energy for this time, it doesn't really matter which one. So I'll need to know what the energy is, and I'll need to know what the time is. So let's read this question. He does 1 chin up, which is an increase of 0.4 meters. We've got a mass and we've got a gravitational field strength. So that's quite interesting. So I would start off by working out how much energy he gains. So when his centre of mass goes from here to here, it's increased its height by 0.4 meters. I'm going to work out how much energy he gains for every pull-up. So we know his mass, we know gravitational field strength, and we know his change in height. So the mass was 65, it tells us in the question. We know gravity, 9.8. And we know that every time he does one pull-up, he goes up by 0.4 meters. And that gives us 254.8 joules. So that's for one pull-up. So let's label that. That's only one pull-up. However, in 60 seconds he managed to do 12 of these, well, chin-ups, not pull-ups. So I'm going to multiply this by 12 because he does it 12 times. So his total energy gain is actually 3057 joules, 0.6. So 3057.6 joules. So I now know how much work he's done, how much energy he's done, and I also know how long it took him to do it. It took him 60 seconds to do those chin-ups. So I'm going to do 3057.6. I'm going to divide that by how long it took, 60 seconds. And that gives me 50.96. So I'm going to round that to 51 and its power, so the units will be watts. So notice I've done this in 2 halves, so I'd recommend splitting your page in 2 if you can. Step 1 is to work out the energy, then you work out the power. So energy first, then power. So you've got 3 or 4 examples here. For the first few, you're going to be working out potential energy. Same with this one, potential energy. This one's also potential energy. This one is elastic energy. So for this one, it's slightly different. You're going to use E equals a half KE squared. And this one is thermal energy. So you'll use this equation from the last lesson. But for each one you'll be doing, once you've worked out the energy, you do power divided by time. Once you've had a go at these, please check your answers. I've given you responses here. Thank you.